So today we'll be factoring expressions where the a value is not equal to 1. You'll always notice that when I'm working with these, I always take a look at my equation, which is right here, for example 1. And what I always do is I always check to see if there's a GCF and take it out. Basically, in this case, I don't have one, so we're done. There is no GCF that all of them can be taken out, other than 1. Now, what we're going to do is we're going to try next, and we're going to work on splitting the middle term. Now, we have to take a look at the 4 and the 3 of this problem. So we're focusing on the 4 and the 3 of our problem. So we're looking at the A term and the C term of our problem. So in this case, we need to make sure that we are taking a look at what A times C is. In this case, A times C is 12. Based on what we're looking at, if we look at this work that we did yesterday, all we did was take a look at the n term, because if you think about the terms that we were using yesterday, we had problems that looked like this: x squared plus 3x plus 2. And all we were doing was taking a look at the last term in our list, the C value in our list, and finding two numbers that multiplied to 2 but then added to 3. In this case, we would have had 1 and 2 being our values, and then we would just write our brackets. Well, x plus 1, x plus 2 would be our factored form. Now, it's similar in the sense that if I had looked at the original equation here, there's a 1 in front of x squared, so technically we did the multiplication of 1 and 2 to find out that we were going to use that as our calculation. And this time we're taking those numbers and adding to 3. Now, the next thing that we have to do is we have to take a look at our problem. We have to find, remember, our problem was this equation up here, 4x squared plus 8x plus 3. Now, what we need are factors of 12, because 12 is 4 times 3 in this case. But then we have to look at the center term of our values, and we have to take two numbers that add to 8. So here are the factors of 12. So in this case, we'd say the factors of 12 are 1 and 12, maybe 3 and 4, and 6 and 2. And when we check these, 1 plus 12 is equal to, well, that's just 13. 3 plus 4 gives us 7. And 6 plus 2 gives us 8. In this case, we're going to use 8 for our value. So now let's go back up and we'll see how we use this in conjunction with our problems from before. Now, back to the original problem. When we're actually writing out these problems, we always kind of write off to the side, multiplied, and we're always thinking about the AC term. We multiply to, well, 4 times 3 is 12, but then we also add to, well, B, which is 8. And remember, B is this. So now, what we're going to do is we're actually splitting the middle term. Another word for splitting is, you'll hear mathematicians call it decompose. Decompose. All right. In mathematics, mathematicians will call this factoring by decomposition. Now, how we do this. So now we're going to multiply to 12, but add to 2. And we found our two numbers when we said that they were 6 and 2. So now what we're going to do is we're going to rewrite our equation to be 4x squared. We leave the middle term and we add plus 3. And then I'm just going to write 8x becomes 6x plus 2x, if you think about it. So now that we have 6x plus 2x, we're going to actually use what we were doing before. We're going to use factor by grouping. Now, the decomposition of 6 and 2 is what allows us to do that. So now we're going to have 4x squared plus 6x all in one bracket. And then you'll notice here we've basically put all of that stuff that's underlined in blue in one bracket. And then what we're going to do is we're going to do the same for the other half of the equation. So I'm going to underline that in green and make green brackets for it. Now, in doing so, we now have the ability to factor by grouping. If we look at the GCF of the first bracket here, you'll notice that the first bracket is literally going to have 2x as its common factor. And in this case, the GCF gives us 2x, and then all we do is we just divide. 4x squared divided by 2x is going to be 2x. And then 6x divided by 2x is going to be just plus 3. And we do the same for the second half of our bracket. But when you look at the second half of our bracket, you'll notice there's nothing there, and we cannot common factor this. So in this case, you assume that the number that you factor out is 1, and so we end up with 2x plus 3 in the second bracket. And now we factor by grouping. So the LCM of both multiplicative complexes here and here is going to be, well, 2x plus 3. And then we're left with 2x plus 1 in our second bracket. I almost think of the second bracket as my garbage collector. Alright, pause here and we'll try the next problem. Same pattern. Okay, so here we go. For this next problem, we have 4x squared minus 13x minus 12. In order to do this, we need to take the multiplication of the two terms in front and in back. So in this case, we have the multiplication of 4 and negative 12, and that gives us negative 48. And we must add to the middle term. The middle term is negative 13. This problem is peculiar in the sense that we have a negative 48 here and a negative 13. Because it's negative 48, you got to realize that one of the variables is, one of the numbers that multiplies to 48 has to be negative. Now, if you look at the middle term, it's negative, so it's going to have to be the bigger number of the two. So, normally when I do this, I just take two numbers and I check, okay, all right, let's do, well, 6 times 8 is 48. That doesn't work. I'm going to cross that one off. Let's try another one. 16 times 3. Oh, that works. 16 and 3 works. But one of them must be negative. The question is which one. So when I look at this, 16 and that, so because it's negative, because the middle term is negative, I'm going to assume that the bigger number is negative. So now let's go and split our problem. Just like before, I write my front and the back term of my problem, and then I'm going to go and identify the variables that I now decompose or split. In this case, something a little peculiar. I'm going to put plus 3x here, and then minus 16x, just to highlight a concept I want you to remember for. Okay, so now what we're going to do is we're going to go and bracket half of our problem. So this is the first half of our equation, and this, all the way from the minus sign all the way to the end, is the second half of our equation. So now when we do this, our next problem is we end up with something like this. And we have our equation set up like this, just like before. Now, if I look at the first bracket, you'll notice that I have 4x squared plus 3x. And you'll notice that the only thing that they can do, there's no GCF other than x. So we'll pull that out. So we end up with this. X bracket 4x plus 3. And now, let's look at the second half of our problem. You'll notice I have negative 16x minus 12. What I want to do is I want to pull off the minus sign in order to ensure that the second half of the equation looks like the first. So we're going to pull off a minus and whatever GCF we have here. In this case, we're going to have the following. We're going to have basically plus the quantity. Here it is. We're going to pull out negative 4, because negative 4 divides both 16x and negative 12. And then we're left with 4x, because negative 16 divided by negative 4 is 4x. And then negative 12 divided by negative 4 is plus 3. And now, our greatest common factor between both multiplication complexes is 4x plus 3. And we'll pull that out. And then what we can do is we put the remainder of stuff in there. So from the first bracket, we're going to have x left, and from the second bracket, we have plus minus 4, which is just minus 4. And we're done. And that's how you do the basic decomposition using method 1, i.e. splitting the middle term.